Imagine an AI that can just dive into incredibly complex software, sniff out the bugs, and then fix them all on its own. It's one of the biggest promises in tech right now. But what if we could take it a step further? What if that AI could learn from the collective wisdom of every human programmer who came before it? Well, that's exactly the idea we're going to unpack today.
So here's the thing. Today's AI coding agents, they're really powerful, no doubt. But when you throw them at messy, complex, real-world problems, they fail a lot. And the reason is actually pretty simple. They're basically operating in a closed world. They try to solve every single new bug completely from scratch, totally ignoring this massive history of problems that humans have already figured out.
Think about it like this. Imagine a brilliant detective, right? They've got all the latest and greatest forensic tools, but they've never studied a single past case. They have no experience to draw from. And that lack of wisdom, that's the fundamental problem we're talking about with these AI agents. I mean, GitHub is an absolute goldmine of knowledge with millions upon millions of solved bugs. But for an AI, it's just a chaotic mess. The data is all unstructured, it's full of chatter, different coding styles, missing info. It's just noisy. There's been no good way for an AI to actually learn from this huge vault of human experience. Until now, that is. And this is where a brand new framework called MemGovern enters the picture. So if the AI agent is our brilliant but inexperienced detective, you can think of MemGovern as the master librarian, the one who builds a perfectly organized library of every single case ever solved. MemGovern's whole mission is to take that chaotic, messy history of human bug fixes on GitHub and just transform it. It carefully curates and standardizes all that data, creating this pristine, searchable library of experience that an AI can finally understand and, more importantly, learn from. So how in the world does MemGovern pull off this magic trick, turning all that chaos into perfect clarity? Well, it all comes down to a really clever pipeline it uses to build its library of experience. It's this super rigorous three-stage process. First, it sifts through everything on GitHub to pick out only high-quality projects with complete bug fix records. Then it standardizes all that data, cleaning it up and reorganizing everything into one single consistent format. And finally, it actually uses another AI for quality control to verify every single entry and make sure that library is absolutely rock solid. And this is what you get at the end, a perfectly structured experience card. Now, what's so brilliant about this is the design. It cleanly separates the problem, which you see up top in the index layer with all the searchable symptoms, from the solution, which is down below in the resolution layer with the actual logic of the fix. This clean break is absolutely crucial for the AI to learn effectively. Okay, so MemGovern has built this incredible library. We're talking 135,000 of these pristine experience cards. The next huge question is, obviously, how does the AI agent actually use this library when it faces a brand new problem? It uses something way more sophisticated than just a simple keyword search. It's called Agentic Experience Search. And it's basically a smart, multi-step process that's designed to mimic how an expert human developer would actually research a problem. It lets the agent not just find stuff, but explore and reason about past fixes. The agent really has two main tools at its disposal. First, it uses searching to quickly scan the top layer of millions of these cards, just like our detectives scanning the summaries of old case files. Then, once it finds a few promising leads, it uses browsing to dive deep into all the details of one single card to really understand the root cause and the strategy behind the fix. Okay, the whole theory sounds fantastic, right? A curated library of human knowledge and a smart AI to search it. But this is science, so we have to ask the big question. Does any of this actually work in the real world? Let's just put it plainly. Does giving an AI a library full of human experience actually make it a better coder? Does it really solve more bugs? And the answer is a big, resounding yes. On the incredibly difficult SWE-bench benchmark, MemGovern gave these AIs an average performance boost of 4.65%. Now, I know what you might be thinking, 4.65%? But in the world of AI performance benchmarks, that is a massive leap forward. And this chart really shows it wasn't just a fluke. Just look at that consistent improvement across a whole range of different AI models. It doesn't matter if it's a top-tier model like GPT-4 or a smaller one, MemGovern provides a significant boost to all of them.
it effectively raises the IQ of any coding agent you pair it with.
And let's look at a really concrete example, because this makes it so clear. On the left, you've got the AI agent without experience. It makes a really clumsy fix. Yeah, it stops the program from crashing, but it breaks the software's internal rules to do it. But on the right, the agent with MemGovern's guidance, it understands the deeper context from a past case and implements this elegant, correct, and truly human-like solution.
The researchers themselves really summarized it perfectly. The standard AI applies a defensive bypass. You can think of that as just a quick patch. But the MemGovern-powered agent, it uses historical logic to create a semantically correct fix. It's literally the difference between slapping a bandage on a symptom and actually curing the disease.
And when you kind of zoom out and think about it, you start to realize that this breakthrough is about so much more than just helping AIs fix software bugs. The whole method that MemGovern uses of systematically taming this messy, unstructured human data into a clean, agent-friendly library, that's a blueprint. You could use this exact same approach to teach AI from our collective knowledge in other super complex fields. Think law or medicine or scientific research. This work really opens up a fascinating new frontier. It's not just about building AI that can reason from scratch. It's about creating AI that can truly stand on the shoulders of giants by learning from all of our shared human history. Which, of course, leaves us with one last, really tantalizing question. What becomes possible then?